curve has equation y equals 6x, take away x root x. We want to find the coordinates of the stationary point of the curve. So in other words, the point where the gradient is 0, so we're going to need to differentiate. Well, the first thing is to use our knowledge of indices. And x root x, remember, is x to the 1 multiplied by x to the half, and you add the indices in this situation, so that's x to the 3 over 2. And now we can differentiate. No, it doesn't become dy dx until you actually differentiate. This is still y. So that's going to be 6. Take away 3 over 2, x to the half, which is 6 take away 3 over 2 root x. So we want 6 take away 3 over 2 root x to be equal to 0. So 3 over 2 root x is equal to 6. So root x is equal to 2 times 6 is 12 divided by 3, which is 4, which gives me that x is equal to 16. So if x is 16, y is going to be 6 times 16, take away 16 root 16. So that's 6 lots of 16, take away 4 lots of 16, which gives me 32. Don't forget you've got a calculator. So 1632 would be the stationary point. Now we want to determine the nature of the stationary point. So we might be able to do that using d2y dx squared, the second derivative. So if we differentiate dy dx again, the 6 will disappear, and then the half comes down and multiplies, so we get negative 3 over 4 x to the negative a half, which is negative 3 over 4 root x. And d2y dx squared evaluated when x equals 16 is negative 3 over 16, and that's negative, which implies that we have a local maximum. So finally, we want to find the approximate change in y when x increases from 4 to 4 plus h. So this will be our x value, and this is our delta x value. And we know delta y is approximately dy dx delta x. So dy dx was 6 take away 3 over 2 root x. So we've got 6 take away 3 over 2 root 4, that was our x value, times h. So root 4 is 2, so 6 take away 3 that becomes, so it's going to be 3h.